Good morning students, welcome to our next lecture of Q data structure. In our previous lecture we studied about the introduction of Q, the basic principle of Q, and then we studied the two most important operations of Q, the insertion and the deletion. Now in today's lecture we will study about different types of Q. That means Q can be of more different types according to the elements that can be stored in that queue. So firstly, discussing about the first type of queue is DQ. DQ means double ended queues. Such type of queues in which element can be inserted and deleted from both the ends of the queue, that type of queue is known as double ended queue. So according to this figure, we are having a queue. In this queue we are having 6 elements. These 6 elements can be inserted from both the ends and also can be deleted from both the ends. So both the ends, that means the front end and the rear end, both will act as the front and the rear according to the operation that is being performed. So suppose that this is our front end. From front end we are inserting a new element and deletion can also be possible from this front end. Now considering this second end, that is the rear end, from rear end also we can insert a new element and delete an already existing element. So both the operations can be performed from both the ends. That means insertion of a new element and deletion of already existing element can be performed from both the ends. That's why we are calling it a double ended queue, because both the ends are performing double functions of inserting a new element and deleting the already existing element. Now the double ended queue can further be divided into two types. First one is input restricted DQ and second one is output restricted DQ. Considering input restricted DQ, in input restricted DQ, the new element that we want to insert in our DQ, that new element can only be inserted from one end, but the element already present in that DQ can be removed from both the ends. That's why we are calling it input restricted. Input restricted means the new element that we want to insert in our DQ, the new element can be inserted from only one end, but element can be deleted from both the ends. And in output restricted DQ, as the name suggests, output restricted means the new element that we want to insert in our DQ, that new element can be inserted from both the ends, but the already existing element that we want to delete, that already existing element can only be removed from only one end. That's why we are calling it output restricted. Now try to understand the terms. Input restricted means we are restricting the input to get inserted only at one end. So this name is already suggesting input restricted means input of new element or insertion of new element will be done only from one end, but deletion can take place at both the ends. Whereas in output restricted DQ, the insertion can be done from both the ends, but we are restricting our output. That means we are deleting an element only at one end, because we are restricting our output. So in second case, that is output restricted DQ, we can delete element only at one end, but insertion can take place at both the ends. So this was about DQ. Coming towards the next type of queue are priority queues. Priority queues are such type of queues in which insertion of elements, deletion of elements are done normally, but the operations on those elements that have been inserted in our priority queues, the operations on those elements will be based on the priority. Priority means the element, the task which is more important will be processed first, and the task which is less important will be processed later. That's why we are calling it priority queues, and we are using priority queues for implementing job scheduling in a time sharing operating system. Suppose that we are having a time sharing operating system, that means operating system is performing tasks on a time sharing manner. That means different time slots are given to different jobs. So this time sharing operating system will process the jobs according to the time assigned to them. So the job with higher priority will be processed first in that time duration, then after processing that higher priority job, next somewhat lower priority job will be processed. So priority queues are used for implementing job scheduling in a time sharing operating system, where jobs with higher priorities are to be processed first. So for this purpose of job scheduling, we are using priority queues. Jobs with higher priority will be processed first, and jobs with lower priority will be processed last. Third type of queue is circular queue. In circular queue, we are using an assumption that array is circular in nature. That means the location 1 comes after location 0, location 2 comes after location 1, and so on. Considering this example, we are here having this location 0. First element will be stored at this location 0, then second element will be stored at location 1. So location 1 is connected, is coming after location 0, location 2 is coming after location 1, location 3 is coming after location 2, and so on. So the last location of this array will come after the first location of the array. That's why we are calling it a circular queue. In circular queue, the element will be inserted at the front end and deleted from the rear end. It will follow the basic principles of normal queue. So the insertion and deletion will always be performed in FIFO principle that we discussed in our first lecture of queue. FIFO principle, that means whenever we are inserting any new element or deleting any existing element, the principle that is to be followed will be first in first out. That means the first element that we inserted in our circular queue will be the first element that will be removed from our circular queue. So these were the three different types of queues. Again summarizing, first type of queue was double-ended queue. Such type of queues are known as double-ended because in this type of queue the operations of insertion and deletion of elements both are taking place at both the ends. That's why we are calling it double-ended queue. Double-ended queue are further divided into two types, input restricted and output restricted. In input restricted DQ, we can only insert a new element at one end, but deletion of already existing element can take place from both the ends. Whereas in output restricted DQ, the insertion of any new element can take place at both the ends, but deletion can take place at only one end. Priority queues were used for job scheduling in a time sharing operating system. That means whenever we are having a number of jobs and those jobs are sharing a fixed amount of time, so priority queues will work on the priority. Priority queue will first process the job with higher priority, then next process the job with some lower priority. So the firstly higher priority jobs will be processed. Now the question comes, what if two jobs are present and both the jobs are having same priority? Then which job will be processed first? So the answer to this question is the job that whenever we are having two jobs with same priority, then the job who came to the system, who came to the queue first will be processed first. Okay, so always keep this thing in mind. Firstly, in priority queues, higher priority jobs will be processed first. And in second case, when we are having two or more jobs with same priority, then the jobs in the sequence when they entered the queue will be processed. That means the first job will be processed first, then second. Coming towards the third type of queue, circular queue. In circular queue, we are inserting any new element or deleting an already existing element based on the FIFO principle. That means the element that is inserted first will be the element that will be removed first from the circular queue. So this was all about types of queue. I hope you all have understood. Thank you.